Now, welcome to another tutorial. Welcome to another tutorial of ProfLearn. In this particular video, we're going to have a discussion of this paper of physics paper 1H. We are going to discuss what are the main areas and what are the key points you should follow in the process of answering different questions in GCSE Maths paper 2 physics. So in this particular tutorial, we're going to go through the main areas that you must focus as far as this particular exam is concerned. One of the questions that was actually tested here was the question to do with infrasounds. You were supposed to understand what do we really mean by the term infrasounds and which value represent infrasound. Remember, infrasounds are sounds which have frequency below 20,000 hertz. So meaning that the frequency that has below 20,000 hertz is actually 2.2, which was option number A. Moving further to question number 2, the figure shows a technician standing in front of a wall, and then there we are given further information regarding the same. So let me just move this a little bit so that you can be able to see exactly what is being displayed here. Okay, so let's proceed. The speed of ultrasound is considered to be 330 meters per second, and then we are supposed to calculate the time taken. So remember, for you to work out this question, what you are supposed to understand is the concept that speed is equal to distance over time. But also you have to remember the aspect that for speed, for ultrasound or ultrasound to travel to this point, it will be reflected and then it will come back to this. So meaning that it's going to cover twice the distance. So at that given point, you are supposed to remember speed is equals to distance over time. And once you've identified that, you'll multiply the distance between the person and the wall times 2. So 2 times 7.6 over the time taken. And if you work it out, you are going to get your final answer being equivalent to 0.046 as the time taken for that case. Explain why human cannot hear infrasonic sounds. So at this level, candidates were supposed to remember the human hearing range is between 20 to 20,000 hertz. So anything that is below this is considered to be out of the audible range of a human person, a human being rather. And then the frequency here, the candidate was supposed to say the frequency of infrasounds is too low to be detected. So meaning that the the infrasonic sound are below the human hearing range. And then for that case, we're going to say and state our answer as shown here. So basically, you need to remember and understand the human hearing range and what value it is. There is also another question that was tested regarding the determination of acceleration, and this is the usage of force is equals to ma. I suppose that you are given a question like that, you need to remember that force is equals to mass times acceleration. And in this question, the student was given the force, and then we were supposed to determine the acceleration. So meaning that we are to make the subject the formula for us to be able to get this particular mark. Moving further, we can see that we are supposed to calculate the resistance force, but what we need to remember here, when the object was moving downwards like that, it means that air resistance and the weight are the one that are going to contribute to what we call the resultant force. So which means that so which means that for us to work out, because the ball was moving downwards, so the ball was moving downward, which means the resultant force will be moving downward. So it means that weight was greater than air resistance. So which means for you to work out resultant force, it will be weight minus the air resistance. So in that case, you are going to say 2.5 minus r, because the mass of this, the weight of this was actually 2.5. So it will be 2.5 minus r is equals to the resultant force that we were given at this point there. So which means the candidate was supposed to say 2.5 minus r is equals to 0.92. And upon substituting all, working it out, you are going to get your answer being equivalent to 1.58 at that point. Some students are investigating forces, and they use Newton meter to keep a trolley stationary on a sloping runway as shown here. And then this trolley is kept stationary at that point, and the force meter can be able to indicate which amount of force is required to keep it stationary at that given point. By doing this, by doing this at 4 different places on the runway, different forces that can keep this object stationary were obtained, and then candidates were supposed to find the mean. So remember, for you to work out the mean, usually what you do is you add all the quantities that you are given, divide by the number of quantities that are available, and if you work it out, you are going to get your answer being equivalent to 2.4. And don't forget to indicate the units, because units indication is an indication of the mark to be awarded. Also further, we have another question whereby you may be asked to work out the value of h. So this was performed for different forces and for different heights, and then the candidate was supposed to, the graph was drawn, and then the candidate for this particular part was supposed to state the value of F, the amount of force required to keep this object at a height of 0.8. So at that point, what you're going to do, guys, is to extend this particular lines that we are having here. So what I'll do is to extend this line. I'll draw a line here. So let me just show you. I'll try to extend this line beyond wherever it is here. I'll extend it that way. So once you have extended that way, let me just do it a little bit better way. So you draw a line there, and then you try to extend it beyond the point it was. So once you have extended that line, then you go to where you have 0.8. Then because that's the point where we are asked, then you try to draw a straight line from there and check where that line meets the graph. Once you have checked where the line meets the graph, then you shall go now across here and try to locate which point is that, so you can be able to read your value at this level. So you can read your value here, which is indicating the force required when the height is 8. So basically that's what you're going to do in that question. Moving further, and for my case, I got my answer to be 3.1. Determine the gradient of the graph. For you to determine the gradient of graph, you need to identify 2 points on the line that was being drawn, Then at that particular point, you are going to draw a right angle triangle and use it to find rise and run. So gradient is given by rise over run, which means that if you try to work it out, you are going to get your answer being equivalent to 3.93, which is approximately 3.9. And the units for this, because we are talking about force against height, the unit for this we can indicate is already indicated here, 9 Newton per meter. So what I need to mention here is that whenever you are given this question, if the unit is not indicated, it means that the examiner expects you to write the units. But since units are given here, you can comfortably be able to earn your marks without writing it. And question number 3 was a question testing on waves. And candidates were supposed to use the information or the graph that is there to indicate the amplitude. So the first thing a candidate was supposed to identify is the equilibrium position of this wave. This represents the equilibrium position of the wave. And then once you have identified the equilibrium position, and you can see from this particular highest point and the lowest point is 20, meaning the distance between a crest and a trough is 20, then the amplitude is going to be halfway here. This represents the amplitude, and to get that, you're going to say is that basically 20 divided by 2, which is going to give you 10 as shown there. So basically that's what you are supposed to do in that particular question. If you are new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to upload more tutorials, you'll be notified. And in ProfLearn YouTube channel, I usually do maths and physics. So if you are new here, consider subscribing so that anytime I'm going to be uploading more tutorials, you'll be notified. And consider joining our Patreon page so that anytime I have uploaded more tutorials, and also you can be able to access different PDFs that I usually have in my ProfLearn YouTube channel videos. Use the data to determine the wavelength. I need you to understand that wavelength is the distance between a crest and another corresponding another consecutive crest. So for instance, from here to here, we have a wavelength. But also you can be able to look at wavelength as distance for a complete cycle. So for instance, you can look at this from here going, let me just, I think I need to use if I consider this is as a wavelength. So how many waves do I have? How many waves do I have from this end here to this farthest end there? I count 1, 2, 3, 4. So which means for me to get the wavelength, this is 48. So I'll say 48 divided by 4, and that's going to be 12 meters. So each wavelength is going to be basically 12 centimeters shown there. Ah, good. Yeah, so I want to see another guy here who wanted my attention. So let's describe how the student could determine the wave speed of the wave. How could the student determine the wave speed? So we need to mark a fixed distance. So in the process of responding to this question, you have to be very clear the way you are giving your answer. Mark a fixed distance and measure how long a crest passes over the measured distance. And you are going to measure this, or you are going to measure the time using a stopwatch. Then to determine the speed, now you are going to use the formula speed is equals to distance over time. So basically, whenever you're given this kind of questions, remember the quantity that you are being asked, which variables are going, what is going to be used to find whatever you're being asked, right? For instance, here we are being asked the speed of a wave. So what do we need to determine speed? We need distance and time. So in the process of your explanation, you have to indicate that so that you can be able to earn your marks. Moving further to another question, we are told that an earthquake happens, waves are transmitted through the earth, and the diagram is represented there. State one example of a transverse wave. Remember, transverse waves are types of wave whose whose particles, where particles vibrate perpendicular to the direction of the wave. And an example of a transverse wave is actually light waves, all waves in the electromagnetic spectrum. All the waves in the electromagnetic spectrum are transverse waves. And if you move a wave, a rope up and down, it's going to display transverse wave. And also water waves are actually transverse waves, because particles in water, they move up and down, which means transverse waves are characterized by crests and troughs. A point in the cross labeled R, the figure, R is this particular point that we are talking about here. Describe the effect. Then a point on the cross R in the figure, there is a rock at point R, there is a particle at point R. So meaning that if there is a rock at point R, this rock is going to experience the wave that is going to pass at point R. So which means that that rock is going to vibrate. The rock is going to vibrate perpendicular to the wave direction. Because we understand that these particular waves that we are talking about, they are transverse. So the particles vibrate perpendicular to the direction of the wave. So you should have indicated that. The speed of the wave is basically 4,500 meters per second. Calculate the distance. We need to remember that distance is time times speed. And once you've understood that, you can now go ahead, use the time that is provided here in order to work out in order to work out the distance traveled between X and L. Then to find X and R, because X and L, we are working with X and L, we are going to get the time taken using the formula. We are going to get the distance traveled using the formula that is given here. Now, once we have gotten that distance, to find the distance XR, you are going to take 20,000 minus the answer that we had gotten, because here you are given 20 kilometers. So which means that from here you can be able to convert this into meters and then apply that. Question 4 is about using radioactivity, is about the topic radioactivity and nuclear energy. And at that given point, you can be able to see that the question is asking about gamma radiation. So what kills bacteria is the ionizing radiation of gamma radiation. Which part of the nuclear reactor is used to absorb neutrons? And that is actually control rods. Those are control rods. And we have an isotope, and we are supposed to work out the percentage of fluorine that remains after 150 minutes. So what a candidate was required to do in this particular question is to go to 150, draw a straight line and check which value is there, and then go across here, check which reading is at this given point. So with that, you can now be able to say 20 over 50, or which was the original, because the original was 50, so it's 20 over 50 times 100, which is giving us 39% that is basically remaining. Describe what happens when a positron meets an electron. Whenever a positron meets an electron, so what you need to understand here, this is a particle and its antiparticle. So when a particle and the antiparticle meets, annihilation takes place, so that gamma photons are emitted, which go in opposite direction to conserve momentum. So you are going to say, as they collide, they annihilate. They collide and annihilate, releasing a pair of gamma radiations. So the moment you are going to have an electron colliding with a positron, then they are going to fuse, and in the process annihilation takes place, and then we are going to see gamma photons. Gamma photons, pair of gamma photons moving in opposite direction to conserve momentum. Yeah, so we also have a question to do. Explain what happens to one neutron as the neutron interact. Huh? 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 That one? So whenever we have, because this is nuclear fission in chain reaction. Nuclear fission is whereby unstable uranium-235 absorbs a neutron and then it splits, and a heavy nuclear splitting into lighter daughter nuclei. So usually what happens is that when uranium-235, which is quite versatile, absorb a neutron, it becomes more unstable. Then it's going to disintegrate. It splits into two daughter nuclei, which are lighter. Then in the process, extra neutrons are produced, which are going to react with, you can see other neutrons are being produced, which are going to react with other uranium-235. Again, this is going to split, and so which means that the process is going to continue endlessly and becomes a chain reaction. So we're supposed to explain what happens when one neutron interacts with one uranium-235. This is exactly what happens, as I've stated here. that when uranium is absorbed into uranium-235, what usually happens is that uranium-235 becomes more unstable. So as it becomes unstable, it's going to split into daughter and lighter nuclei and releasing extra more neutrons and together with gamma rays in that process. You are supposed to give the ratio, and in this case just you are to take the value that we are having here, divide by this value that we are having at this point. But also you have to remember that giga in physics means 10 raised to power 9. So that's why you can see I've done this conversion at this given point. And that, if you worked out, you get your answer being equivalent to 0.49. Moving further, we have now to move to light. So we need to move to refraction of light. Candidates were supposed to describe how the student could use a glass block ray box to produce a refracted ray and mark its position. So which means that whenever you are given this question, you need to understand the ray box has a purpose of producing a straight ray of light, and then you are going to direct that ray of light direct to the glass block. After tracing the outline of the glass block, you are going to draw a normal on one side that we are having at this given point. So once you have drawn the normal, then you are going to direct the ray from this particular point into the glass block. Then you will observe how the ray is going to travel, and then you are going to trace the path followed by the ray of light along inside the glass block as shown there. So this kind of questions is very important for you to draw a diagram so that you can easily refer the instruction. You can easily refer and set the apparatus as shown above, and then direct a ray of light from the ray box towards the glass block at the normal, and then trace the path through which the ray approaches the glass block and how it leaves the glass block. So basically that's a summary of what you are supposed to say in such kind of question whenever you are given a question like that. We have also a question to do with how frequency and wavelengths are changed as the ray of light is moving through a glass block, and you need to realize that wavelength of light increases as it travel from glass into air, because air is less dense, so the wave is going to speed up, so the wavelength is going to increase. State what happens to the frequency as it's moving from one medium to another, i.e. from glass to air or from air into glass. Frequency remains unchanged. Frequency does not change. Frequency remains the same. Yeah. The speed of light is 3.0 times 10 raised to power 8. Calculate the change in speed of blue light when it travels from air into glass. When it travels from air into glass. So we need to check what is the wavelength in glass, is this, and what is the frequency in glass, so that we can be able to calculate the speed. And remember, for us to work out the speed when this is moving in glass, so whatever answer we are going to get here will be the speed in glass. So using the wave equation that is provided here, and now you are using the medium glass, then we can be able to get the speed being equivalent to that. So meaning that if you work out speed, you are going to get your speed being 2.24 times 10 raised to power 8. And that is because we used wavelength being equals to this, and frequency being equal to that. So something that I need to remind you at this point is that nanometer means nanometer is the same as 10 raised to power negative 9. So meaning we had to convert this to meters by multiplying by 10 raised to power negative 9. So another area that was quite important for you to to remember. So once you have gotten the speed of blue light in glass, then you, because the question was asking us to find or to calculate the change in speed. So change in speed is going to be speed in air minus speed in glass. So that's why you can see I did the subtraction at this given point, and that gave me a value which is 7.6 times 10 raised 7.6 times 10 raised power 7 meters per second. That's the change in speed. Question number 6 was about energy transfers, I think, and the types of energy: kinetic energy, gravitational potential energy, GPE. And we were given the gravitational potential energy was provided. We are given the mass, and then we are supposed to work out the height. Quite interesting. And for us to work out that, you can now see that we can rearrange this particular equation that we are having here in order for us to find the value of h. We just need to rearrange the formula. Now, once you have rearranged, you're going to say GPE over mass times gravity is going to give us the height. And if you work it out, you're going to get your answer, which is going to be approximately 56 meters. Yeah, because we are talking of the height, so you have to ensure you remember the units that I give. You should give your answer. But now in this case, our life was easy because already the units was provided in this question. You are not supposed to write the units. No, you are not supposed to write the unit because they were given out. Then we are told the sky starts from rest. So at the top is at rest, meaning the initial velocity is basically 0. And then we are told velocity at the bottom is 27. So which means this is the final velocity. And we were supposed to work out the acceleration. So we shall just use the relationship v squared is equals to u squared plus 2as. Now, in that particular point, if you rearrange the formula, you are going to get your acceleration being 1.8 meters per second square. So that's what you are supposed to do as a candidate in that particular point for you to earn your marks. Explain how to determine the amount of dissipated energy. Remember, as this car is sliding down the inclined plane, there is air resistance, there is friction, which is actually trying to oppose the motion of this person. So which means that energy is dissipated, not all the gravitational potential energy. At this point we have GPE, and at this point we have kinetic energy. Not all the GPE will be converted to kinetic energy because there is dissipation, there is energy lost. As the person is coming down, is actually working against air resistance. There is friction between these skates and the surface, and then now you find that energy is lost in form of sound, in form of heat to the surrounding. Now, for that reason, that's why the examiner now is asking you to state how to determine the amount of dissipated energy. So for you to determine the amount of dissipated energy here, you are going to say measure the GP at the top and also measure the GP the kinetic energy at the bottom. Because this is conservation, energy is being transferred from one form to another, then meaning that we expect the energies to be the same. But since at the lower end we are going to have less energy, then it means some energy was dissipated. So which implies that at this point, dissipated energy will be the energy at the top minus the kinetic energy at the bottom. Just leave a comment in the description. Let me get to understand if you've understood how to work out this question, and let me get to know whether the video was helpful to you. And don't forget to subscribe and also like this video and share this particular channel to your friends to help me grow at this channel. Let's move to the next part. The athletes here, you can see they are negotiating a corner. That's what I want you to realize. The athletes are going around a corner. Yeah, they are negotiating a corner, isn't it? And which means that we are having an aspect of circular motion, an object moving around a circle. So that implies that even though these these athletes are moving at a constant speed, their velocity is changing. Velocity is changing because the athletes are changing direction. Velocity is the scalar quantity. State why velocity is changing even though they are moving at a constant speed is because they are changing direction. Anytime speed is changing direction, it means that is velocity. So it caused kind of a high and thinking question. You had to think critically there. Determine the gradient of the graph at 2.5. So you are supposed to identify where 2.5 is, then you draw a straight line there, and then at that particular point you are going to draw a tangent, and then once you have a tangent right with you, you can now go ahead and draw a triangle, which you are going to use. You use that triangle in order to find the gradient. Now, whenever you have a curve, the gradient at a point is going to be equal to the gradient of the tangent of that curve. So that is basically the logic I'm using at this particular level and at this particular point of time. If you work it out, you'll get a value close to 6.2. So basically, if you work it out, check whether your answer is close to that. Describe how power of a lens is related to the focal length of and the shape of the lens. So this question, what was important for you to remember is that power of a lens is given by 1 over the focal length. That was very important in that particular part. So for you to respond, you'll say the power of a lens is given by this particular formula. So more powerful lens has a shorter wavelength because the wavelength is inversely proportional. The power is inversely proportional to wavelength. So which means that if you need a powerful lens, you have to ensure that it has a shorter wavelength, and a more powerful lens also should have a small radius of curvature, so that you could earn your mark. Give one example of a visual image that lens could produce. A visual image can be produced if the object is placed very a bit closer to the lens, a distance which is a bit closer to the lens. Let me try to draw maybe a converging lens here so that I can be able to show you what I'm trying to say. So if we have a lens, converging lens here, and this is the focal length, and this is another focal length at this point. So if the object is placed between the principal optical center and between the focal length and the optical center, then it means for you to obtain the image, you are going to draw a ray that is running straight from the top of the object. When that ray meets the lens, is going to be refracted such that it's going to pass through the principal focus on the other end, like that. Okay, another ray that is going to be produced is a ray that runs from the top of the object through the optical center of the lens. So if you notice, these rays are diverging, they are moving apart from each other. Oh, okay. So for you to obtain the image, you are going to extend this ray backwards like that. You are going to extrapolate the lines like that, and then you are going to have a visual image produced at that point there. But in the case whereby we're talking about a real image of a lens crop produce, you will the image distance object by a converging lens. So basically that's how you are supposed to respond to these questions that were given here. Then part C, we are given a semicircular glass block, and the student investigates what happens when the ray of light shines onto a semicircular glass block of a transparent plastic. Yeah. Oh, you know. So this case, you can see there is a ray that we are having on this particular end here. So which means that this angle, as this angle increases, what I'm trying to say is that if we have this ray here, as you try to increase this angle, what is going to happen is that this ray also down here, the refracted ray is going to be approaching the lens. So the moment the angle of incidence in the glass is more than the critical angle, so let me just do that. If this angle is more than the critical angle here, so if you keep on increasing this angle, to a point where the angle is more than the critical angle, then it means you are going to have now total internal reflection taking place. So all the rays will be inside the glass block, and now in that case, angle of incidence is equal to the angle of reflection, because total internal reflection has basically occurred. So describe what we'll expect to happen as the angle of the straight edge increases from 20 to 50. Remember, we were told the critical angle was 38. So what do we expect to happen as this particular angle that we are having inside here, as this angle increases? That's the question that we are being asked. As this angle increases, what will happen to this ray? So that's exactly what we're going to respond in the question here. We're going to say, as the angle of incidence in the glass block, increases, angle of refraction outside the glass block also increases. When the angle of incidence is 38, the angle outside the glass block will be 90 degrees. So basically there, what we're trying to say is that when you'll be having an angle here, this angle being 38 degrees, the event will be having this angle 38 degrees. The angle of refraction here will be 90 degrees. So that's why the critical angle is defined as angle of incidence in the dense medium when the angle of refraction is 90 degrees. Okay, so once you have mentioned that, you are also to complete by saying when the angle of inside is greater than 38 degrees, then total internal reflection will occur. Then in such kind of a case, angle of incidence is going to be equal to the angle of reflection. So you are supposed to state those points in that particular order so that you could be able to earn the three marks. We have asteroids, chaos, orbit the sun. Okay, so let me see. This part C, then we have part D now. Asteroid chaos orbit around the sun between Mars and Jupiter. During its orbit, chaos receives electromagnetic radiations from the sun. The average temperature is constant for this particular asteroid. Why? Why is the average temperature constant for this asteroid? So here, what we needed to understand as candidates is that this asteroid absorbs the electromagnetic radiation, the infrared radiation, all the thermal energy from the sun. As it absorbs, it's going also to emit because if a substance absorbs some heat, it also gives out that heat out of it. So meaning that chaos absorb electromagnetic radiation, and the rate of absorption is equal increases. Also the rate of emission also increases. So which means that the more the heat this particular asteroid absorb, it also emit the amount of heat. So the temperature is going to be constant in the condition that the amount of heat absorbed is equal to the amount of heat emitted. And that is the logic we are supposed to give in this particular question. So you can be able to write this. I've written it in step by step so that you can be able to exactly see how this is supposed to be basically done. And then you can move to question number 8, and then we are supposed to state the unit for momentum after calculating momentum. Remember, momentum is given by the formula is equals to mass times velocity. That is the formula for momentum. In this question, mass is 0.43, and the speed also we were told is actually 3.6 meters per second. If you work it out, you're gonna have your answer being equivalent to that. The units for momentum is kilogram meter per second. Now calculate the amount of time that the footballer kicked. So you need to remember that impulse is equals to change in momentum. Impulse is equals to change in momentum, and impulse is calculated by F force times time. In this case, we were given the force in this particular question. The force was given here, and the mass, of course, we have worked out the momentum, but initially the ball was stationary. So momentum before was 0. Final momentum was 15. So meaning change in momentum will be 15 in that particular case. So if you work it out, you're going to say the force 2700 times time is equal to the change in momentum. If you make time subject, you are going to get your final answer being equivalent to 0.0057 seconds. Then we have to explain how Newton's third law play a role here. What you are supposed to remember as a candidate is that Newton's third law states that Newton's third law states that for every action force, there's equal and opposite reaction. So in that case, that means that if the footballer kicks the ball, the force the footballer exerts on the ball is equal and opposite to the force the ball exerts on the foot of the footballer. So you are to identify that and also remind the examiner that the Newton's third law, how Newton's third law states. And basically that's exactly what I've highlighted at this given point here. Well, we have a question number part B of that. We are told that we have two trolley here. This trolley is moving, but this other trolley that is at this given point here is stationary. So which means that its momentum is 0. But the momentum of this will be the mass of S times the speed at which it was moving. But the examiner was asking with reference to momentum of the system. Tende. Chukua mtoto. So the question that the examiner wanted us to respond at this given point is to indicate why the velocity of the trolleys after collision is less. So as a candidate, you need to remember the law of conservation of momentum, that momentum before collision is equals to momentum after collision. So at that particular point of time, so in that way, we had to remember the law of conservation of momentum and say that momentum before collision is equals to momentum after collision. So if the system that was moving, if this is the trolley that was moving here, meaning that momentum before collision will be the momentum of this trolley. But now after they collide, they are going to combine and move together. So which means the total mass will be greater. So since the total mass will be more than the previous, yeah, so which means that we are going to say before collision, I need to write this properly so that you can be able to see what I meant. Before collision, momentum is equals to what? Mass of S. Mass of S times the velocity at which it was moving. Then we expect also the momentum after collision to be the same as the previous. But since the mass will be greater after collision, then speed has to be less. Speed has to be lower. So that more mass times a smaller speed to give us the same momentum. So in this question, momentum has to be conserved according to the law of conservation of momentum. So after collision, combined mass of the system is greater, so velocity of the combined trolleys must be less than the velocity of S. Yeah, I hope you've understood how this is arrived at. And we have carbon 14. We were supposed to state the unit of activity of the sample. Units for activity, radioactivity is actually becquerel. Yeah, so becquerel like that, which is represented as BQ. We have the table gives correct comparison penetrating abilities. Starting with the lowest, it means it's alpha, beta, and gamma. So something that you need to remember, if you have paper, if you have aluminium, if you have aluminium, and if you have thick lead, so you can say this is paper, we have aluminium, and we have lead. Then it means if you have alpha particles, they can be stopped by paper. They cannot penetrate paper. Alpha particles have low penetrating power. They cannot even penetrate through skin. Then if you have beta particles, they can penetrate paper but can be stopped by aluminium. And then if you are having gamma radiation, which are electromagnetic in nature, can be stopped by thick lead or concrete. Yeah, so basically that's what you are supposed to understand in this question. Calculate the kinetic energy. Kinetic energy is given by the formula kinetic energy is equals a half mv squared. So which means that we have the mass, we are given the speed at which it's moving. Then we were to work out this comfortably in order for us to get the answer there. So don't forget that you have to square the speed in that particular question for you to get the correct answer. Don't forget to square the speed. Yeah. And if you work it out, you get 6.6 times 10 raised to the power negative 18. Moving to describe what happens to the nucleus of when it's emit beta particle. When the beta plus particle is emitted, the mass number stays the same, but the atomic number decreases by 1. But if it was a beta minus, the atomic number or the proton number will increase by 1. This is a beta plus. So if it's a beta plus, remember, atomic number decreases by 1. If it was beta minus, it will increase by 1. Beta minus, increase by 1. Beta plus, decrease by 1. Radioactive decay can produce gamma radiation and alpha radiation. Compare the process of gamma decay and alpha decay. Your answer in description of both gamma radiation and alpha radiation. So you must describe what is an alpha radiation, what's a gamma radiation. You have to describe that. That has to come out from your answer. And that is why I started by saying alpha radiation consists of helium nuclei containing 2 protons and 2 neutrons. I've described what alpha is. Decay. What alpha is. I've tried to describe what alpha is. And then I went ahead to describe it further, and I said they have a charge of +2 when alpha particle is emitted. Now, effect on each type of decay. Now I'm moving to the effect on each type of decay. So how did I go ahead of that? Now, effect for each type of decay. Let me just remove that so that I can use this. Yeah, effect on each type of what? Decay. So I started here. When alpha particle is emitted, proton number decreases by 2 and the mass number decreases by 4. So the nucleus changes to a different element. Done. Done. Then I moved now to gamma radiation, and I said now in the description of who gamma radiation is, who is gamma radiation? Gamma radiation is a guy who is made of high frequency electromagnetic radiation. So I started gamma radiation. I'm trying to make the examiner understand. I have met with Gamma, Mr. Gamma. I've interacted with him. I know who gamma radiation is. So in that way, I started by saying, yes, sir, I know it's high frequency electromagnetic radiation, has no mass and no charge. Now, let's go ahead for this second part. What happens during the decay of gamma? What happens is this. During gamma decay, the nucleus loses excess energy and become more stable. During gamma decay, the nucleus is not transformed. It's only that the nucleus loses excess energy. So the element does not change. And we need also to mention something to do with penetration and ionization ability of each of these two guys. We say alpha radiation is highly ionizing and weakly penetrating, while gamma is lowly ionizing but highly penetrating. So basically that's what you are supposed to state in this question for you to earn a whooping 6 marks. Not a joke. It's not a joke for you to earn these marks. You have to be very, very clear in the way you are giving your answer, in the way you are explaining yourself for you to earn these particular marks. Just leave a comment in the description if this question could make you cry. If you got this question, if it could have made you cry. Let me just get a comment below. If this question could have made you cry, if you are doing it. Yeah, so, and also if you have understood, write the comment understood. Moving to question number 10, we are given a table of different stars. We have Antares, we have Arcturus, we have Proxima Centauri, and the Sun. So the question is, which one is most likely to become a black hole? Remember, we have different life cycle of stars. A star starts as a protostar, main sequence, red giant, white dwarf, and black dwarf. Or if it was very, very massive, it was a massive star, it will move from protostar, main sequence, a red supergiant, it becomes then a supernova, then it can either become a black hole or a neutron star. So what determines whether a star is going to become a black hole is the initial mass. So which means if it was massive like this one here, is going to be what? Become a black hole. So Antaeus is likely to become a black hole because it was the most massive star in this particular table that we are given here. And that is actually part B. There was a question on that. You are supposed to take because it had the greatest mass. That's why basically I selected this in this particular part. During nuclear fusion reaction, mass is converted into energy. Describe what's meant by nuclear fusion. Nuclear fusion is a process of combining lighter nuclei under high temperature and pressure. So to make a heavier nucleus like that. So you need to understand what we mean by nuclear fission and nuclear fusion at the same time. Speed of light is this, and then we are told in energy is radiated in 1 second that states the decrease in mass. We are going to use this formula that we've been given here. So I decided to rearrange this equation so that I can be able to make M mass the subject, because the question is asking me about to calculate the mass. So I had to do the arrangement. And if I worked it out, I got my answer being equivalent to 4.3 times 10 raised to power 9 kilograms of mass. Oh, yeah. So we have some bits remaining here. And here we are going to talk about Big Bang theory. We know Big Bang theory is the theory that tries to explain the origin of the universe. How did the universe, where did the universe, when did the universe, where did it come from, and when was it made? And of course, we know that the best explanation has been that is scientifically proven is Big Bang. But in this question is talking about us to discuss evidence of Big Bang theory. Whenever you are going to see a question to do with evidence to show Big Bang theory, you must remember about light from distant galaxies. They show a redshift, which means that which is an implication that the universe is basically expanding. Yeah, so since the light from the galaxies, light observed from galaxies shows a redshift, it means that the universe is what? The universe is expanding. That's the evidence, because Big Bang theory claims that the universe originated from a single dense point, a single hot dense point, and that point, or that single dense point, expanded to whatever we have. Yeah, that the universe originated from a single dense point which expanded over time. So since the universe is basically expanding, it means that different galaxies are going to be separated, are going to be moving apart from each other. So since the universe is expanding, it means light from distant galaxies is going to show a redshift, because the galaxies will be moving away, and then due to Doppler effect, the observed frequency is going to be, or wavelength, the observed wavelength is going to be longer. Another aspect that you are going to look at in that question is the presence of microwave background radiation, the presence of CMBR, microwave background radiation in that is present everywhere, which means that during Big Bang, the universe was hot and dense, so which has meaning that the universe, since the universe is expanding, then it means that the universe has cooled over time, and the background microwave, the radiations, the gamma radiation that were initially there, have stretched and have shifted to the microwave section. So that's why I say that in this particular evidence, you to look at the stretched wavelength, redshift, and also the presence of microwave background radiation. So in your answer, you must say the following: that light from distant galaxy shows redshift. This cause is caused by, I have to cancel this. This is caused by Doppler effect. The fact that nearly all galaxies show a redshift, it means they are moving away from us. Further distant galaxies, they show or display a larger redshift, which means they are moving away faster. This supports Big Bang theory because it shows the universe is expanding. If the galaxies are moving away, if the light from galaxies, the galactic redshift is being displayed, it is an indication that the galaxies are moving away. And the reasons as to why the galaxies are moving away is because the universe is expanding as claimed by Big Bang theory. Then CMBR is microwave radiation detected everywhere in all directions. According to Big Bang theory, these radiation are leftovers of the Big Bang that took place billions and billions of years ago. So, and they have cooled over time. So basically, that's what you are supposed to do in this particular paper. And if you are new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to upload more tutorials, you'll be notified. I believe you got value from this particular tutorial, and if that is the case, don't forget to subscribe and also share this channel to your friend. See you in the next one.